thing you need to know are the place values. And a lot of students think that they know the place values. Most students do know the tenths, the hundredths, and the thousandths. But this is the ones place, and we do deal with that, the tens place and the hundreds place. So that will come into play as we're going throughout this unit. Rounding. Students always seem like they know how to round, but there are some students that don't. So let's go through the rounding rules to make sure that you do, in fact, understand what's going on. You always look one place value smaller than what you need to round to. If you're rounding to the ones place, you need to look at the tenths place. So in this number, if we had to round to the ones place, that's where this 3 is. We have to round to that ones place. We would look to the tenths place. If it's a 5 or greater, we would round up and we get 124. If it's a 4 or lower, we would round off and we would have 123. Well, rounding to the ones place, you look at the tenths place. Mention that again. If the tenths place is a 4, 3, 2, 1, or 0, you round off. So in this case, this is a 4 in the tenths place, so we round off to 123. If the tenths place is a 5, 6, 7, 8, or 9, you round up, so 123.5. So this is greater than a 4, it rounds to 124. Again, most students do seem to know about rounding rules. So again, if it's 5 or greater, you round up. If it's less than 5, you round off. So let's do some rounding. We're going to go to the ones place with all of these. So what we do is we want to round to that place, so we look at the tenths place. If the tenths place is a 5 or greater, we round up. So our tenths place number is definitely greater than a 5, so our answer is 1. Why don't you stop the video at this point in time and go ahead and do the rest of these, and then I will go through them when you start to play the video again. So in this place, we want to go to the ones place again. We look at the tenths place. The tenths place is a 4, so we round off. In this place, we want to go to the ones place again, so we look at the tenths place. It's a 4, so we round off. We want to go to the ones place, but we look at the tenths place. It's a 5, so the answer is a 1. All right, in this one, we want to go to the tenths place, so we want to round to that tenths place. Why don't you pause the video and see how you do? Keep playing the video, pausing the video as you're going through. So we want to go to the tenths place, so we have to look at the hundredths place. The hundredths place is greater than a 5, so it means we round up. So we have 9, 9, 9, 9, and then we round up to a 5. We want to round to the tenths place, so we look at the hundredths place. The hundredths place is less than a 5, so we round off. Want to round to the tenths place, so we look at the hundredths place. We don't care about these 9s. They're not the hundredths place. We just look one place value smaller than what we need to round to. So we don't let all those 9s influence our answer at all. So we got to round to the tenths place. That's this 4 right here. We look immediately behind that. It's a 4, so we round off, and we get a 4. Again, we want to go to the tenths place, so we look at the hundredths place. So 5 point, and the hundredths place is greater than a 5. It's a 5 or greater, so we round up, so that's 5.5. All right, now we want to go to the hundredths place. Why don't you pause the video, give yours a shot. I will go through all of these. All right, so if we're going to the hundredths place, we got to look at the thousandths place. If it's a 5 or greater, we round up. If it's 4 or lower, we round off. So we got 100.4. And now we look at the hundredths place, which is an 8 here. We look at the thousandths place, which is a 9, so we round up, so 49. We want to round to the hundreds place, so we look at the thousands place. Thousands place is greater than 5, so it means we're going to round up. So we got 7, 7, 7, 7. And all right, so let's look at this. So this is going to cause this to round up to a 10, which will cause the 4 to round up to a 5. If I left it at that, I'd be going to the tenths place. We need to go to the hundreds place, so that's why that is the answer. That's one of the more tricky rounding questions. We want to go to the hundreds place. We want to go to the hundreds place, so we look at the thousands place. Thousands place is greater, 5 or greater, so we round up. So 0.01. Again, we want to go to the hundreds place, so we look at the thousands place. It's a 4. We don't care about all these other digits. We just look one place value smaller. The only digit that influences anything is the digit one place value smaller. It's a 4, so 0.01. Doesn't matter about all those other digits. All right, now we're going to do something different called scientific notation. We're going to be using this a lot. It's a skill that you must own. These are 2 examples of scientific notation, so what it looks like. I'm going to take you all the way through it, following the sheet. So there are some rules, and these rules can be found on your unit pack cover on the back side. It says there can only be one number in the front of a decimal point. So that means in scientific notation, 1.23 times 10 to the 5th, 4.89 times 10 to the negative 3rd. There can only be one number in front of the decimal point, and that one number can't be a 0. So that's kind of one of the main rules. 2, you need to count the number of place values. The decimal will be moved, so the decimal is behind the first non-zero. The number of place values the decimal moves is your exponent. So if we look at this example right here, this is scientific notation right here. How many spots did I need to move the decimal point? I needed to go 1 spot, 2 spots, 3 spots, 4 spots. So that's where this 4 comes from. I had to move it 4 spots, and that's where the exponent 4 comes from. Numbers less than 1 will have a negative exponent. So if this number was less than 1, we would have a negative exponent. And if numbers greater than 1, have a positive exponent. So this number is definitely greater than 1, so the exponent is a positive 1. Again, these rules are found on your unit pack cover and on your periodic table. This number is smaller than 1. We need to recognize that. Writing it in scientific notation, we put the decimal behind the first non-zero number, so that's the 9. We write the times 10, and we had to go 1 spot, 2 spots, 3 spots, so that's where this 3 comes from. But since this number is less than 1, we put a negative exponent on the number. So 9.8701, you write times 10. And we had to go 1 spot, 2 spots, 3 spots. So that's the 3. And since it's a number smaller than 1, we put a negative exponent. Yeah, I mentioned that right there. Many of you have different calculators, and we need to be able to find this on your calculator. So what our goal is to type this into our calculator, 9.8701 times 10 to the negative 3rd. The crazy thing is we never actually hit the multiplication sign, the 10 button, and some other button to get an exponent. We use other buttons to do that, and it makes life a little bit simpler. So the first thing we would do is we would type in this into your calculator. Then we got to find what kind of calculator you actually have. So this calculator right here is the most common calculator. You would hit the second button, and then you have to go right down here above the 7, and it's EE. So we actually need the EE function on this calculator. On this next calculator, we actually hit the times 10 to the n button, which is right there. On this other calculator, it's kind of nice. They actually have an EE button right there for us. On the Casios, they have an EXP button down there in some varieties. And on other varieties of Casios, they have this times 10 to the X button. Those are all buttons that you need to be aware of on your particular calculator. So if we're typing this into our calculators, we need to push or type in this number. We need to hit the EE button, the EXP button, or the times 10 to the X button. Again, we don't actually push times 1, 0, and a button. We use a different button for that. We hit the negative sign, which is not the same thing as the subtraction sign. We push a 3, and if we press enter, we should end up getting a decimal, 0.009870. If that does not work for you, please come in for help. Most students can do math and chemistry, but sometimes the calculators get in the way and cause issues. So here we go. There's no need for calculators on this next part. So what we need to do is we need to write the following numbers in scientific notation. So again, we need to go 1.000. We put the decimal point after the first non-zero, so it goes after the 1. How many places did we have to move it? We had to move it 1 spot, 2 spots, 3 spots, so times 10 to the third. Is this number smaller than 1? Yes, it is smaller than 1, so it gets a negative exponent sign. We need to move this decimal point behind the first non-zero, which is behind the 9. So we go 9.8000 times 10. And we had to move it 1 spot, so it's 1. And this is a number smaller than 1, so it gets a negative exponent. Yes, we need these zeros, and we will talk more about that in the next couple days. Why don't you try this next number, these next 2 numbers yourself? Pause the video, try it, and I will go over them. So in this problem, it is implied that the decimal point is there even though there is no actual decimal point. So we need to move the decimal point from there all the way over there behind the 1. So 1.2345 times 10. And we have to move it 1 spot, 2 spots, 3 spots, 4 spots, 5 spots. So that's where this 5 comes from. And since this number is definitely greater than 1, it gets a positive exponent. So we just leave it as a 5. It's implied that the decimal point is right there. So 1.1 times 10. And we had to move it 1 spot. So times 10 to the first. And there's that work for you in a prettier version. All right, you try this and then replay the screen. So stop the video, try these, and then see how you do. So in this problem, here's the decimal point right here. I need to move it right there. So 8.765 times 10. I had to move it 1 spot, so that's where the 1 comes from. This whole number is less than 1, so it gets a negative exponent. 1.05, decimal goes behind the first non-zero number, times 10. Now I got to think. This number is greater than 1, so that means I get a positive exponent. I got to move it 1 spot, so it's times 10 to the first. I have to move the decimal point behind the first non-zero, so 1.2 times 10. And I have to move it 1 spot, 2 spots, 3 spots, 4, 5, 6, 7. 7 spots. This number is less than 1, so I get a negative exponent. In this number, it's implied that the decimal point is right there, even though there's no actual decimal point. Decimal point goes behind the first non-zero. Times 10. I had to move it 1 spot, 2 spots, 3, 4, 5 spots, times 10 to the 5th. Again, there's a prettier version of what I just went over. Convert the following numbers that are in scientific notation to decimal form. So in other words, what is this number as a decimal? All right, so this requires a little bit more thought. So I have 9900. Decimals right here, I need to make it 1 spot, 2 spots, 3 spots. So that would be my number. A little bit more difficult to go this way, but it kind of shows you what the number actually means. This 0 is always shown just to point out that there is an actual decimal point there. Why don't you try the next 3? Pause the video, try the next 3. So we got 1, 2, 3, 4, 6. Decimal points right there. This tells me the number's got to be smaller than 1. So I have to move it 1 spot, 2 spots. So that 1 is in the 2nd spot. All right, so we got to move this. It's a positive number since it's got a positive exponent. Right here's the decimal point. We got to move it 1, 2, 3, 4, 5, 6, 7, 8 spots. So that is our number. And in this number, we got the 1.1. This has got a negative exponent, so it means it's smaller than 1. So we have to go 1 spot, 2 spots, 3 spots, 4 spots. So there we move it. So 1, 2, 3, 4. That's where we get that negative exponent from. Again, there's a prettier version for you to look at. Convert the following numbers that are in scientific notation to the decimal form. So again, why don't you try these on your own? See how you do. So right there's the decimal. It's to the -3rd. So it means I got to make a number smaller than 1. You can throw a whole bunch of zeros up here if you want to. I got to move it 1 spot, 2 spots, 3 spots. So right there is my decimal. 7, 8, 9. It's a number smaller than 1. Right here's the decimal. I can throw a bunch of zeros up there to start off with if I want to. I got to move it 1 spot, 2 spots, 3 spots, 4 spots, 5 spots. You get my number. So this -5 tells me I am 1, 2, 3, 4, 5 spots from the original decimal point. This next number is greater than 1. I can throw up a bunch of zeros and erase the zeros I don't need. Right there's my decimal. I got to move it 1, 2, 3, 4, 5, 6. I can move the decimal point right there. I can get rid of that 0 if I need to. And this number is a positive exponent, so I'm going to have a number greater than 1. So 8, 9, 0, 9, 8, 7. Decimal point is right there. I need to move it 1 spot, 2 spots. So it's 890.987. So right there is your work. Numbers that are greater than 1 have exponents that are positive. So 5.5 times 10 to the eighth. This is a positive exponent and therefore would be a number greater than 1. While numbers less than 1 have exponents that are negative. So if I put a negative sign there, would mean we have an extremely small number. So your homework, go to It's Learning, click on Boot Camps, and do the rounding and scientific notation quizzes that are there. You're aiming for a 90% or better on these so you understand these concepts. These concepts are used year-round, so you really need to take them and understand them. Come in for help if you need to. Have a good day.